than we did yesterday. We're going to go into how this stuff all works. So, Sid, why don't you say hi to everybody? Let's see if we got both on.
Hello, everyone, and I hope you had a great lunch because you're going to need it. You're going to need the energy from what we're going to be doing now.
Can you guys hear that all okay? Anybody out there hear him?
Hello? Hello?
Hey guys, can you guys hear Sid out there through the speakers? Okay. All right.
Okay, Ken, just one more thing. You may want to take away control from my computer because I may mess you up.
I don't know if I can take it away.
Sure, just give key control just to Ken.
Yeah, I unchecked it. It worked. Okay, good deal. All righty, I'm going to go ahead and put your video away for now.
No problem.
And what
Turn off my camera.
Okay, what we're going to be doing today, we're going to be talking about how these technologies work. Sid and I are both co-partnering on driving all this AFRM stuff, so as you guys start to play around with this stuff, if you have questions, please feel free to contact either one of us, and you might want to jot these email locations down if you don't have them. Okay? Biggest question that I think needs to be answered is where do you get information on how this all works and what the definitions are and so forth. There's going to be a lot of this stuff that's going to be changing somewhat over the next year or so. Some of the text that is in the help documents right now is not perfectly accurate because we've made quite a few changes in the last 3 months, and some of that needs to be caught up. But bottom line is there's some online help documentation in the help text that you guys can go to and will give you a lot of information about how this all works. Okay, so definitely get in there and take a look at this. To find it, go into the SolidCAM help text, navigate into the index or the context, the contents, go down and find your automatic feature recognition and machining, open that up, and you'll find all kinds of data under there. There's a bunch of it, okay? Study into it, and you're going to understand a lot more about how this works. What we're going to talk about first is what makes this do what it's going to do. The segment configuration browser is basically something that you're going to see in here, okay? This is the area that is going to be identifying what happens when a particular geometry segment is discovered by the feature recognition technology. There are several types of segments. There's a drill segment, there's a flat cylinder segment, chamfer, flat chamfers, threads, and reaming. We may make more in the future. We don't know yet. We're discovering stuff as we go along, okay? But what is that? Well, this is an area that organizes these technologies into groups. And so when I talk about a technology, they're going to be based on the type of feature segment that is discovered, okay? What is a segment technology? What is one of these icons? Essentially, it's a container, okay? Within that container is the specific machine process that is going to be used to machine that particular segment geometry when it is discovered by the automatic feature recognition. Okay, so one of the things you're going to see, guys, there's a lot of confusion about this throughout the world. A lot of people think this is very, very difficult stuff to work with. It's really not that bad. It is fairly straightforward, and once you understand the fundamentals of how this all works, it's not terribly difficult to change or to make, build your own. We're going to kind of show you a little bit about that today. But essentially, this container holds a machine process definition. And as I said before, it's based on the M feature, based on the feature type. Well, what is the M feature? That's that group of types that we just went through there, the different types of geometry that it's going to see when it analyzes the model. Another area of great concern is the conditions frame. Well, what does this do? That's this section up here. Notice it's empty right now because I'm not highlighted on any of the containers. So if I highlight technology, notice that there is a group of functions that happens here that it addresses. Well, what is this? This is just a simple ladder logic. This is very, very simple. It doesn't do a great deal of functionality. It's a simple if condition. There is no else. The else is it goes on to the next container. So if these conditions are not met, it simply falls out of that, goes and looks at the next container, and the conditions for that container, if it finds those in the geometry that it's discovered, then it'll work the machine process that's in there against that geometry. If it doesn't find it, it'll move on to the next one. It's really that simple. Okay? So what do we do with that? Well, we're going to use expressions and values and conditional checks against it to determine what should or shouldn't be done by this particular machining principle that you want to apply when it finds these geometries. And an expression is really just either a variable that we've used from the system or a formula. It could be variable divided by 2, or it could be, you know, whatever formulas you come up with. And the limit in this is kind of your creativity. Okay? The tangency of a 30-degree angle times 5 times the HR parameter of the segment diameter or something of that nature. Okay, you can come up with all kinds of crazy stuff to do in here. Or it's testing the condition of a particular item. Okay. Now we also support 2 logical operators. That is and or. And we'll show you how that is used in the system here in a little bit. But basically, let's talk about what's going on here. This is a drilling. Okay, so we run the automatic feature recognition, and get that out of the way. It discovers a simple cylinder, right? So it looks at this and it says if the HR segment diameter is equal to or less than the max tool diameter. Max tool diameter is a user parameter that we built. Okay, it's right here. Well, if I can find it, here it is, right here. The max tool diameter has a value of 25 for this particular scenario that I decided to write. Okay, there's no reasoning. I can't tell you what the right and wrong way is to do this. You have to choose that when you build this. We decided for what we were going to install, the maximum tool diameter that we want to use for a drill would be up to a 1-inch drill, okay, or up to a 25-millimeter drill. Beyond that, we want to do something else. We don't want to use this technology. So in our scenario, we simply said our max tool diameter is going to equal 25. So if the HR segment diameter is less than or equal to 25 millimeters, and the HR segment diameter is less than or equal to the max single drill diameter, we set a max single drill diameter at 12 millimeters. We have 2-step drilling down here also. So the first check is to determine if we even want to apply this technology to it. The second check is to determine whether we want to use a straight drilling operation or whether we want to move to a 2-step drill where we'll pre-drill it with a smaller tool, come back with the bigger tool, and open that hole up further. Okay? Again, don't get too locked in on exactly what I'm doing right here. Try to get the concept of what you have the availability of doing. Okay? Because in the 2-step drilling function, and I'll get to it in a little bit when we talk a little further about what we're doing with the operation. In a 2-step drilling, it's greater than the max single diameter. And so we're going to create a machine process that has 2 drilling functions in it. One is a pilot hole, one is the full size. Okay, because in this particular scenario, maybe we've got a low horsepower machine. I don't want to take a 25-millimeter drill and try and pound it through steel. I want to go in with up to a 12-millimeter, pre-drill it, then come back with the 25 and finish it. Okay, so that I'm putting less horsepower requirement on the engine, on the motor. Okay, so back to this. Now, also, we may want to look to a height, a tool extension, or something of that nature. And again, you can get as creative as you want. Your customers are going to know how they do their strategies. And that's what I was saying yesterday. this opens up an opportunity for you guys to generate revenue, because you can sit down, it's kind of like a post-processor. I want to build some custom functionality for a user. If the hole is meeting these conditions, we want to machine it this certain way. If it meets these other conditions, we want to machine it a different way. So it's kind of that ideology in here. You can move through it that way. So if the height to diameter ratio is less than or equal to the max drill height ratio, then we're going to go ahead and run this. Now, sorry, I forgot to clear this back. We were playing a little earlier. That's all I wanted to check in here in this particular drilling. So if it meets these conditions, then it will fall into this container and do the things that are inside that container. Does that make sense?
Yeah. Ken, why don't you just, Ken, let me just interrupt you for a second. Why don't you just right-click on drilling and show exactly what we're talking about when we're going into the container?
We will in just a minute. Hang on a second, Sid. I'll get through a couple of things before we go inside the container. Okay. But we'll do that, yeah. And that's what we're gonna take you next. Okay. Sorry. No problem. No problem. I just wanted you to see what the and/ors are doing. Okay. By basing it on, I want to check this and I want to check this, or if it's this, then I want to do these other things. Okay. That's the kind of functionality that's available to you in that conditions segment. Now, the other frame that you see in there is the user-defined variables. And this is where you can describe particular variables that you want to use for whatever reason. Okay? And we're going to show you in a little bit. We're going to build an arbitrary variable that we want to use to check something that is going to be used in another variable. Okay? So right now, in the AFRM technology, or in the AHRM, by the way, AFRM is automatic feature recognition machining. That incorporates pocket recognition, drill recognition, chamfer recognition, hole recognition. In the AHRM, we're looking at automatic hole recognition machining. In the automatic hole recognition machining, the user-defined variables in here that you can create on the fly for the conditions to check which container you want to be in are simply floats. They're numeric variables. We don't have conditions for true, false, or for text or anything like that yet. Okay? We may get there. We don't know. We haven't seen what we need to see in that yet. It would be nice to have some stuff in there like that for colors and things like that. So I'm sure text will come in, because then we can capture the color of the feature and look at that. But basically, you can create a parameter in here by simply typing it. And this is what I was playing with a little earlier. If I wanted to create another function for this, when I hit that OR, notice it brings up another line. Now, I can go in here and I can look at the user-defined parameters, and it'll give me a list of these parameters that already exist. If I don't want to do that, if I need a new one, I want to create my test bar, whatever, okay? Then notice that becomes a parameter down here, all right? And I can assign a value to it. I can assign a hole recognition parameter. If I go into the hole recognition parameters, we can see HR segments, things of that nature. If I go into another user-defined parameter, I could pull in a user-defined parameter, make it a combination of several. There's all kinds of things you can do here. But basically, if you create a parameter by simply typing it in here, it will put it in this list and make it available for you to use in a logical condition check. Does that make sense? Okay. All right, so let me clear this out. Okay. Where are these files all stored? Okay. This is, a lot of people don't know where this stuff is. So we want to talk about that just a little bit before we get deep into the tips and tricks of it. Sorry, I went forward too fast. These are based on your SolidCAM settings. Wherever your system additional files are stored, that's where it's going to look for these database files. And so as we go into here, let me cancel out of this and bring it back in. If I go to the technology database, notice it's going to go to that folder. All right? and I can grab, we're looking at the TDB files. TDB stands for Technology Database. With each TDB, and this, the SHR one is the one that will be in there by default installation, and that is the System Hole Recognition Database. All right? You can name others whatever you want. Like I created one to play with here so I didn't wind up screwing everything else up. It's just called SolidCAM World 2015, whatever you want to call it. You could also create one for aluminum, one for steel, one for titanium, on and on. Whatever reason you have for differentiating between one table or another, you can name that table that way. Different machines, exactly, exactly. There's so many different ideas here. It's really wide open. Now, with each of those, there will be a folder. And what is in that folder is going to be all of the different machine processes that you build. Okay? Now, don't go in here playing around deleting or renaming things. You'll mess the whole system up. Okay? If you copy these, or if you want to make a copy of these so that you can start changing it and working with it, you're going to want to copy both. I wouldn't do it, if you're going to start out, you're going to grab these two, for instance. Okay? Let me cancel out of here and go there in the file organizer. Okay, so if I came in here and I wanted to make a copy of one, I would grab the SHR folder and the TDB. And then I could simply drag them off, make a copy of it here, rename it, and then I could go back into the system and begin working with that and making changes to it. Okay? So what gets installed with the system, you guys can very easily start to play with by simply dragging off a copy and go play with that. Now you're not going to wipe out the system one. If you blow yours up, okay, you learned something. All right? Throw it away, start over, make another copy, and continue. You want to make a copy for one machine to another, or from one material to another, you can do that. Simply go in and change your feeds and speeds to accommodate that new material. Makes it very simple. Okay? Yes, you can do that too. Yeah, absolutely. I'll get there. Yeah, I'll get there. But there's ways you can do this inside or outside. What I wanted you to understand is the file structures and where they are, not just from inside the dialog. I would recommend doing the save as inside the dialog because the system then is going to manage it. You're not going to take a chance of misnaming it or forgetting to grab the folder or anything else. But I want you to see where these are also. Okay? All right, so what he was just talking about, let's say I'm in this one right here. Oops, my bad. And this one here. We have a save as function here. Okay? That's been created recently. That never existed before. But now you can do the save as, and it does exactly what I just showed you manually. It takes and makes a copy of both the TDB and the folder in that same location, and then you can rename it to whatever you want to name it to. Okay, so that's where they're stored. That's where the files are located. But where do we go with this right now? There's a lot going on with this, guys. A lot of work happening here. And I'll tell you right now, Sid and I got some ideas on this stuff, and we're talking to other various people throughout the organization and getting their ideas. We really want to hear from you guys what you want this to look like. How can you use this in the field? How can this help you with sales? Okay. My personal philosophy, I don't want to build anything that doesn't help you sell more software. If it doesn't help you sell more software, why would we waste our development time on it? Okay? Because development time is a premium. These guys are very busy. So we need to hear from you guys what will make this give you a better opportunity to sell our software. How can you leverage this to close more deals? If it's associativity, if it's automation, in another idea from what we're doing, those are the kind of things we need you to feed back to us. So as you start to play with this and you get ideas, I want you to really think about what impacts sales, because that's the whole key to what we're here about, okay? There's going to be a lot of ongoing construction on this. We're making changes to it. We're learning things as we go along. We're discovering what more we can or can't do, and we may have to get pretty creative with some of it. But let's go ahead and build one. Now, the one we're going to build today is going to be based on the whole wizard technology, not on the whole recognition. So we're going to kind of shift gears a little bit and come out of the whole recognition and go into the machining process. And I'll show you how they're related. These engines kind of use each other, all right? So as you guys begin to understand more about what this is in the software, there's some connectivity, some interconnectivity between these two functionalities. When you use drill recognition, for instance, the drill recognition is using the HR recognition engine to analyze the geometry, all right? When you build a technology in the HR, it is using a machine process technology to build those little machining operations that you're building into those containers. So it kind of goes across all of these different technologies and uses each of these different modules. So we're going to work with the machine process and go into the fundamentals of that today. And that's about all the time we're going to have, is to build a simple one in there. But understand that in the machine process that I showed you yesterday for the whole wizard recognition, we're actually using HR to discover the geometry of that hole and recognize that it was built by a whole wizard in SolidWorks, then tell us to go look at the extended data to capture the variables out of the extended data. Okay? So these are all interconnected throughout the whole thing. If this gets a little confusing, I apologize. We're trying to push a whole lot of information into a very short time span here. Sid, talk to us a little bit about some of the things we need to pay attention to before we start building the process.
Okay, does everyone hear me well?
Say again?
Does everyone hear me well?
I think so.
Okay. Well, when we're looking at a machining process, and now what we're talking about now in this particular case is we will be building a machining process based on the whole wizard of SolidWorks. Okay. Now, when we're building a machining process, we have to take into consideration different types of parameters, such as text variables. For instance, if you want to give a name to a specific tool, descriptions for that matter. There are also compound variables for spot drill diameters based on a specific idea. For instance, I want to create a spot drill that's based on the diameter of a chamfer. So these are what we call compound. You're basing one thing based on a different parameter altogether. So in other words, you're taking information that you're getting from one and bringing it over to another to get information to build onto it. I can talk about this all day, but I think the best thing is if we actually go in and start working on it.
Okay. Hey, Sid, I have to pull the microphone up really straight on the speaker, or if you'd be here.
Okay.
First, so let me know when you want to say something, and I'll do that.
Okay.
What I'm going to do, guys, now, I showed you a minute ago the technology database. Okay, we went into the technology database to pull that up. How many of you in here are not familiar with the whole process, the machine process mechanism? Because you guys have all used it? Okay. The machine process is right here. It's different than the whole recognition technology geometry, but it uses the same engine in the background. Okay? So we're going to create a new one. And what we want to show you today is how kind of straightforward this really is to build a new technology. This is not black box magic. It's really fairly simple. So I'm going to build a new milling machine process. We're going to name this whatever, my test process. You need to add a machine to the process. Because if you think about this, we're doing, for instance, in this case, drilling. So we have to look at the BMID and find out what drill cycles are available. So a machine process is really oriented towards a specific machine because it's taking advantage of what that machine can or can't do. And so we're going to assign a machine to it. And in this case, we're going to use the default G-milling that's in here. And we'll go ahead and add any of the similar ones that use the same options. And we're going to say OK. All right, so that created a baseline machine process database. And you can see that here. Now, this says new machine process. If I right-click on it and I go into edit, then I can begin to edit that operation or that process and build operations into that process. Does that kind of make sense to you? So I want to add an operation here. What we're going to do is we're going to add a simple drilling operation, and we're going to make this just a simple hole with a spot drill, just to kind of get you into the idea of building one of these. Now, notice that it brings up a dialog, and that dialog is the same dialog you're used to looking at through the regular system. Guys, you can hard code this all the way down. You can just fill in the data and use it. And now you have a process that you can just pull up and apply to a piece of geometry and bang, you're done. Okay? It's that simple. If you want to take it to the next level, you can begin to parameterize these particular variables within this dialog. For instance, in the levels. Okay? It's already got some of them set up by default with some of the most common ones that are used, like work upper plane, things like that. But let's say I want a variable here. Well, I can use a part parameter. I can use a whole wizard parameter. I can use a user-defined parameter and do anything I want, right? I can also open this up and just put a value in here. So what we're going to do is we're going to start down this. Number one, the first thing we need to do is pick a geometry, okay? And so we want to do a user-defined value for that, so we're going to come back to it because right now we don't have one that we've built into it, okay? So let's go to our tool first. And as Sydney said, some of these parameters need to be predefined right now, and Anna, we probably need to think about how we can make that a little more convenient. Not quite sure yet what we need to do there, but some of the stuff has to be predefined. So like we have to do in some other areas of the software, we can build a lot of stuff in here, save it, go add a function, and then come back in and apply that, if that makes sense. Okay. In the tool, I'm going to select a tool. We're going to do a spot drill. This spot drill has several parameters in here. One of the ones that I'm talking about right now is a description. I cannot create a text description on the fly. Don't know why. One of the things we need to look into and continue to fix. Okay? But right now it won't let you do that. So we're just going to leave it blank, and we'll come back to it in a few minutes. But the diameter I can create on the fly. And I can simply type in here, or I can go into an area where it's a little easier to see, and I can use the edit dialog. All right? One of the rules of engagement that you must pay attention to is no spaces. So think about your naming structures before you start this. I want to create a bunch of parameters that define the spot drill tool. Well, if I just use diameter and my process winds up having 3 or 4 different operations in it, and I've got an end mill, I've got a drill, I've got a spot drill, and I've got a tap, I can't use diameter for all of them, right? They've got to be specific. Because the diameter of the spot drill is going to be different than the diameter of the end mill used to do counterbore. So don't use a generic name. Do something like this. Create spot underscore drill underscore diameter. Okay? That creates a variable for us that we're going to use. Now, little tip and trick, capture the first part of that. Control C. Now I can accept that, and I can go down here and I can say Control V and just add angle. Okay? Accept that. Arbor diameter. Here's one of the things that some people don't think about. Well, I'll just make that the user parameter, and I'll grab spot drill diameter. Well, what's going to happen if I want to change that? Maybe I want to use an undersized one. Well, I can't do that if I've locked it into the spot drill diameter inside this dialog. So what we want to do is you want to create a unique one and call it arbor diameter. Now, we'll come back to that when we get out into the expressions and start to define them out there. We're actually going to tie them together there. Okay. But inside the dialog, give each parameter a unique identifier. Okay. Now, I'm going to show you, you don't have to go into that edit screen. I'm just going to type here, and I'm going to use the acronyms, TL. Okay. I'm going to go into here, copy paste, and use OHL. And then I'm going to go into this one, copy paste, and use SL. Now, will a spot drill ever be calculated on more than one flute? Anybody? Now, feed rates for drills are always computed off of one flute. So do I need a parameter for this? Never going to change, right? So I can leave it hard-coded to 1. It doesn't matter. All right, so that's how easy it is to set this up. You can assign a holder. I don't know that I would recommend that. That's something you probably want to do at the insert of this. If they need holders in, they can go through and assign them after they've inserted them, because you can just do that in the tool table, and it globally handles everywhere where that tool is used. Okay? So at this point, I'm ready to say OK and select it. Now, I'm going to save this. Oops, geometry name's not defined, sorry. We are going to name this here. We're going to call this hole location. Put that in. We're going to save this now and close it. And notice that it immediately dumped all of those ones that we built into here. It even actually automatically knew that this one was a hole location geometry. Okay? So now, let me open this up a little bit more so you can kind of see what's going on in here. Remember I talked about coming back and creating a text? Well, down here in the bottom we can add a new parameter. There are several types of parameters that we can add. Okay? In this case, I want to add a string. And so I want to make this a string parameter, and I'm going to name this, same thing we were naming the other ones, spot drill underscore description. Right? And then I can go ahead and add that in, and it goes into here. It goes into the unused parameters because we didn't put it into the dialog. Okay? But I can very easily go back here now to the edit function, go to my tool, and now I have the ability to select that from the user described. Okay? Again, we intend to make some of this more convenient, guys. This is a lot of work involved in this, and we're diving in both feet and building this. So as we go along, where you see things that are kind of clunky, tell us, send me an email. Okay? I may be focused on something else. Sydney may be looking at other things. Anna's looking at about 50 million things. Okay? So feed us the information, and we'll fix it. So very easy to go in and out of this and create these. Now what we're going to do, Sid, tell us a little bit about spot drill diameter. What's the complexity in it?
Okay, well, spot drill diameter, you have to take a few things into consideration. The spot drill diameters, there are basic standard sizes for a spot drill. For example, there are spot drills that are 6 millimeters, 8 millimeters, 10 millimeters, 12, 16, 20, 25, and you want to make it a variable, or you want to actually give it some kind of condition based on what the hole that you're going to create the spot drill for. So these are things that have to be taken into consideration.
Right. Now let me ask you a question.
Sure.
Are all of the holes the same?
No, absolutely not.
What happens when you have a through hole versus a blind hole? And this goes back to SolidWorks, guys.
Right. Well, we'll take a look at this shortly, but as far as SolidWorks goes, when they give you the information about holes, they give you information for two basic types of holes: a through hole and a regular hole, or blind hole, as we may know it. Now, if a through hole, right, there's two different parameters. So if the hole that you're using is a through hole, then the regular hole diameter will come up as 0, and you'll have a value for the through hole. The opposite is true if it's a blind hole. If it's a blind hole, you'll have a value for the blind hole, but you'll have a 0 value for the through hole. And I think Ken is going to show you exactly how we can use this to our advantage.
Right, so let me show them how that works. So what we're going to do, because we have to test for that condition, I need to create a user variable. And the exercise here is to kind of open your minds up to how to work with this and how to take, we are limited by what SolidWorks gives us, and we have to deal with that in that environment. So I'm going to create a float diameter. Float diameter is just a simple numeric, okay, a real number, and I'm going to call this spot drill chamfer diameter. Okay. Now let me explain what we're doing here. Before we can figure out which spot drill diameter we want to use, we have to know what the diameter of the chamfer we're going to create is. And in order to discover that, we're going to have to get the information from SolidWorks out of the API. And if it's a blind hole, that information is going to be in the HW underscore hole underscore diameter. If it's a through hole, the value for that is going to be in the HW underscore through underscore diameter. So it's two different variables. So before I can test for what the variable is, I have to test for whether it's a blind or a through condition. Okay? So what I'm going to do is I'm going to tell my spot drill diameter that I want to build a condition. And I'm just going to start using that condition, or actually, let's do this here before. Let's make it easier to understand. I'm going to build a condition for this spot drill chamfer diameter. Now, if you've never had any experience with structured logic, this might be a little confusing. If you're used to doing if-then-else conditions and things of that nature for post-processors or anything like that, this is really simple. So as a reseller, guys, you need one of your techs to be very up on this in order to be able to do this. But again, you can make a profit out of this. So I'm going to say if the expression, a hole wizard parameter, and I'm going to look at, what did we do on this? Said we use the hole diameter equals 0?
Right.
Okay, so I'm going to say if the hole diameter
is more than 0,
is greater than 0, did we do it that way, or did we use the...
No, you can do it this way, and so the value is the hole wizard hole diameter.
Right. So if this value is greater than 0, then we're going to use that value. If that value is 0, which would be the else condition, then we're going to use, oops, wrong one, sorry. We're going to use the HW through hole diameter. Okay? So the first thing we're going to test is what we've got here. Okay? We're going to know whether or not we want to go a blind or a through condition. Okay? Hit OK on that, and this takes on a value. Okay? Now we can look at some other conditions. To spot this right to that size, we can build a condition in here, and this is going to get, you can make this very simple or you can make this very complex, depending on how granular you want to select your tools. You want to use a 6mm tool for certain size, an 8mm, a 10mm, 12, and 25, or do you want to use, I'm going to use a 10mm for everything under here. Next one I'm going to go to is a 16, I'm going to go to a 25. Okay? However detailed you want this to get. Myself personally, I like to set these up real close so that if I'm up against a wall, I'm not using this huge spot drill to spot it and tearing my wall up. Okay? You're going to have more success with this automatically functioning if you use the spot drill as close to the size you need as you can get. All right? But let's just do something simple here. If the user parameter chamfer diameter is less than or equal to what do you want to use? Say 7?
Say 7. Okay.
Okay. Then we're going to use a 6mm spot drill.
No, an 8mm.
Oh, I'm sorry. Went the wrong way. Okay. Else if, notice we have an else or an else if. Else if the,
nope.
Oops, wrong one. My bad. Slipped. Come on. Slipped on the pick. User defined parameter. Else if the chamfer diameter is greater than 7 and let's just go ahead and
copy paste,
capture it, paste it. For some reason it didn't copy it. It's less than or equal to,
say 11.
Yeah, let's say 11. Then we'll use a 12mm. See the idea here? Okay. We're going to make this simple. Else
25.
Use a 25. Okay. So we just built a conditional that looked at what was discovered and determined which spot drill it wanted to use. Okay? Yes? Mm-hmm. To the geometry, right, to apply to the analysis of the geometry. Mm-hmm.
Okay, Ken, can you repeat his question because I can't hear him when he asks it, please?
Yeah, hang on a second, I'm waiting to get it. Okay, let me, okay, hang on a second. What he's asking is, he doesn't want to build the tool, he wants to choose the tool. Right now, what we're doing, we've got one level of check in there. If a tool exists in your tool table that meets the criteria of the check, it will use it. If it doesn't exist in there right now, it builds it. Okay? One of the things that we've talked about is creating a hierarchy where if it's in the tool table, use it, else go look at a user-defined table path, like you may have a global shop library versus a project library. Look there. If you don't find it there, build it. Okay? That's not been built yet. Right now it looks in the tool table. If this condition exists in a tool in the tool table, it will simply use that tool. If it does not exist, it will create a tool that meets the criteria. Make sense? Okay. All right, so now the next thing we want to do is we want to look at the spot drill angle, right? So we're going to create a condition for that looks to the hole wizard and looks at the near countersink angle. If the near countersink angle is greater than 0, then we want to use it. If it's not, I'm going to use a 90-degree spot drill. Okay? Whatever decision you want to make. Maybe in your shop you use 82-degree countersinks or use 100-degree countersinks or whatever you're doing. Okay? But get the idea here. If we know it, if it exists, if there's a near side countersink in the hole feature from the hole wizard, obviously we probably want to use that. Okay? If it's a sharp hole, no upper countersink, but we want to put an edge break on it, well, then we want to use the 90-degree or whatever you want to use. Right? So you can kind of see what we do down here. Now, remember this one earlier? I talked about using a unique parameter name for each geometric definition of the tool. But for right now, I don't want to worry about undersized or oversized shanks. So I'm going to tell this, I simply want this to be a user-defined parameter that is the spot drill diameter. So now it's going to use the same diameter as what is discovered for the spot drill. So if we decide, based on a conditional check, that we're going to use an 8 millimeter, then it's going to make the arbor diameter 8 millimeters. If the condition test tells it to use a 12 millimeter, then the arbor diameter is going to become 12 millimeters. It's going to follow with it. Okay. What about the tool length? Okay. This is where you got to start making some decisions. Do you want to hard code this? Do you want to use ratios? Okay. What I did is I went in and I looked at the machinist handbook for jobber length drills, and it says in general they're about 14 times the diameter of the tool. Okay. So what we did in here was we decided, all right, we'll just make this a user-defined diameter times 14. And we're going to capture that. For the outside the holder length, we'll make it times 10. And then for the shoulder length, we can do the same thing. Or you could make it 8 times 8, whatever. Okay. You see the idea, what we're doing here? None of this is ever going to be absolutely perfect because we don't know what tools you have in your library. Now, as we go forward with this and we begin to do more development on this whole module, there's a lot of things that we can look for. We're going to build into it the ability to look for the tool length within a range. Okay, and have, if the range, if nothing exists within that range, then build it to a specified dimension. Yes?
And if you install again inside this operation on the left side.
Okay.
Yes. Go to do it.
Yep.
Select. Do you have access to a tool table now?
No, not yet.
Sure. On the left bottom maybe, yeah?
Yeah, but Anna, I don't know, does this work yet? Anna? Does the import from tool table work in here yet? I don't think so. It's something we haven't gotten around to testing yet because we've been focused on getting everything to work.
Ken?
Okay. But, yes.
I think if you do use that, then it's just hard-coded.
Yeah, that's what I was going to say. I think it just hard codes it at that point. Bear with me just a minute and I'll try to explain a little bit about how this all works. In order to pick a tool from a series of tools based on criteria of the tool, you have to have ranges. And it has to ripple through a ladder and figure out this tool, and this tool, which one best fits the range. And it kind of goes to a heuristic. All right? We haven't done that yet. That gets really complicated and real complex. Right now, it's looking for an exact match on the criteria. And so I'm going to recommend that for right now, in this condition, the way this is set up right now, use those formulas like 14 times, 9 times, 10 times, whatever, because then those will always match what you've already created. Okay? As we get further into this and we get some of the baseline stuff figured out, working really, really stable, some of the next enhancements will be to start creating that ability to look for criteria range in a user-defined search path of potential tool tables. I mean, think about tools for aluminum, tools for steel, tools for titanium. Those are different tools. So ultimately, sometime down the line, we're going to be able to look for material criteria as well. Say, if part material is aluminum, look in this tool table. If part material is titanium, look in this tool table. See what I'm getting at? None of that's been built yet. There's a lot of work to build all that. So let's work with what we've got right now, and you'll see what I'm talking about. Let's save that and exit it. So we're almost there. The whole location is going to pick up already. The spot drill description, Anna, do you know if we've got the logic set up yet for the description for the text field? I don't think we're parsing the text yet.
No, not yet.
We talked to Raisa about doing that, but yeah, I don't think it's in there yet. We've got developments working on this where we'll be able to look at the spot drill diameter and utilize that variable within a text description. Okay, so we'd be able to put, for instance, spot drill diameter and then the text, verbatim text, spot drill, so that when it calculated, if it picked an 8 millimeter, it would automatically put the description as 8 millimeter spot drill. If it picked a 12 millimeter, it put it in as 12 millimeter spot drill. They're working on that right now, but I don't think it's finished. So right now, what I recommend for any descriptions is just hard-coded. Now, remember I said no spaces. No spaces is the name of the variable. You cannot use spaces in the name of a variable. But in a text string variable, the value of it can include spaces, okay? Because the space is a text character. So don't be worried about the space in the value. Only worry about the space when you're actually making the name of the variable. But you can kind of see how easy it was to do that. All right, so now I want to save that, and I want to go back into the operation. What's the next thing? We've done the geometry, we've done the tool. The next thing we got to do is the levels. Where do we want this to work? Okay. Well, I don't want to work off the upper plane. I want to work off the whole wizard parameter. Okay. And so, actually, my upper level wants to be a selection. I'm sorry, hang on a second. We didn't do that yet. We need to create a variable called z-value. In our z-value, we're going to name this pick upper level. Okay. Now, let me explain. Right now, we do not have the ability to capture, for instance, the upper geometry of the countersink and capture the Z component of its value. We haven't built that into it yet. So for right now, this is what you and I were talking about yesterday, for right now we have to create a Z-pick function so that you can capture that upper Z value. But by creating that and adding that parameter in, we can now go back into the levels and we can tell this to use pick upper level. Okay? Save it and go on. Now, what about the depth? Well, The depth of our spot drill, because we're going to be using the spot drill diameter, okay, we want to be hard-coded to 0. We want it to use that same surface that we picked so that we can use the diameter value to have it push the drill the right length down. So we're going to set this for diameter value. Anybody? What value do you think we're going to use here? We're going to use the one we created earlier. Okay. So we created a value for that. We can now use that. Now, I haven't gone full depth into this and created that value to be plus or minus or checked on whether or not, you know, if the upper countersink exists, we're going to use it, else we're going to use something else. All right, so you can create all that logic in there, and then you can use that inside here. So sometimes a variable that you create as a user variable can be used in multiple places, maybe even in different fashions, different equations applied to it, but that same variable can be used for others. Technology. We're going to use a G82 cycle. When we go into our data, the dwell, okay? Now, do I want to hard code this? In my shop, we always want it to dwell 0.2 of a second. Another guy comes in and says, oh, no. For titanium, we need it to dwell 0.5 of a second. But for aluminum, we only need it to dwell 0.2 of a second. Yeah, okay. So you can make this a hard-coded variable, or you can make this a variable for the customer that he has control over. How do we apply that? Well, let's apply this as a 0.2 right now and put it in there. If we want a variable to be always hard-coded, put it in there hard-coded in the dialog. If you want the user to have control over that variable, then you need to build that variable, you need to build a variable for that and expose that in the insert. Okay? Now, we're out of time, so let's go ahead and use what we've got here. Okay?
Can you just have one little thing? In the spot drill chamfer diameter that you have over there as a float, you still have the 0 in there. The very bottom. The very bottom. Very bottom. No, the last parameter.
Oh, yeah. Good catch. Sorry about that.
Okay, you can leave it that way, though, for now.
Yeah. What I did, guys, I forgot to overwrite. Sorry, I left a 0 in there, actually. So what I need to do, let's go back here real quick, fix that.
Right, levels?
Yeah, levels right here.
Yeah, F2.
Okay. Well, I forgot to back that out, my bad. All right, so now it'll use it. And that becomes an unused variable that I can delete. Okay, so I'm going to save this and I'm going to exit it. And we have created this structure. Now, if we were to apply that operation, add machine process from MP table, and I want to add this in. Look at how much is exposed to the user. Everything. That didn't gain us anything, did it? Okay. So the one thing I wanted to show you in here is another little item that you have to do if you want to isolate this and make it very, very easy for the user to use this. I'm going to cancel out of that, exit that, and we're going to go back in here. In this process, there's a column over here called ReadOnly. So we don't want the user messing with this. So we're going to make that a read-only parameter. We don't want the user messing with this one. We're going to make it a read-only parameter, and so on and so forth. The diameter is going to be read-only. This is going to be read-only. This one's going to be read-only. Here's read-only. The whole location we need them to work with. We need them to pick it, so we're going to leave that exposed. The spot drill description we might want to leave exposed in case they just want to change it for whatever reason. Okay? This one's going to be read-only. The pick upper level is going to be
yeah, Ken, one more thing you still have to do is in the expression of the pick upper level work, you just have to put the parameter of the pick upper level.
Okay. Forgot that. My bad.
Yeah, that's why I'm here.
Yeah. Okay. So now we created this pick upper level work plane, and I screwed that one up too, didn't I?
Yeah.
Okay, anyway, this variable will pick this one, but this one we don't want to be exposed, so we're going to hide it. But the pick upper level, we do want exposed because we need the user to be able to get to it. Okay, so by creating read-onlys on these, and by the way, you can put descriptions in for each of these so you can identify how it's to be used and so forth.
One note, Ken, over here, in the description can be written in any language.
Yeah, this could be whatever language you want it in. All right. So now I'm going to save and exit that. And we're going to go back and do the input again. Add machine process from table. And we're going to grab this one. Now look at it. Okay. Nice and clean. The only two things we have to do is pick the whole location and pick the upper level. And I've exposed the spot drill so that the user can change this on the fly each time. If I don't want that exposed, for instance, once we get the text description to be able to also use a variable, you may want to just lock that down. Make that read-only. The only two things that are going to show up in here, three things, are going to be the coordinate system, the pick locations, and the pick upper Z. Okay, so you can really refine this down to a very, very tight orientation of how it works. Okay. Don't do that. Why would you do that? Okay, so all right, back to here. Real quick, we're going to go through some of these parameters that you're going to see. These are geometry parameters because when you go to build something for instance, doing the counterbore, you're going to put a profile operation in there. And you're going to identify the things that you want to identify. So some of the variables that are available to you are listed out here. Okay? Here's ones for the countersink. Here's one for a simple hole. For hole wizard parameters. Okay? So we already did the simple one. Question and answers, and we're running out of time. Anybody got any questions? Yes, sir. We will hopefully have all that documented for you. We got some work to do yet.
Okay, Ken, what was the question?
You want to know how does he know which hole wizard parameter to use?
Okay, that's part of the documentation that we'll be doing. That's correct.
It's all going to be part of the documentation that we're going to build. We haven't got. Quite honestly, guys, we started on this what 2 months ago, 3 months ago, basically. So we have been firewalled just trying to get this ready to show here. Okay. We've got a lot of work to do on this still. Hopefully, I think we're looking for Service Pack 2 is where we want to release the whole wizard stuff. Is that kind of what you're thinking? Yeah. This is probably not going to be in Service Pack 1. I mean, the functionality will be there, but there won't be a process installed with the system like we did with the HR database. What you saw me run yesterday is actually in the system install right now. Okay, this data structure that we've got right now is very close, and what Sid and I have built for the metric and for the inch functions will be installed in the software. I don't know if we're going to be able to get it into Service Pack 1. Service Pack 1 is scheduled to be released on the 22nd. You know, unless I work around the clock between now and then, I don't think we're going to get it in there. Okay, but it'll probably be in Service Pack 2 because we got to do some testing on it and throw it against a bunch of different parts and make sure we didn't do something stupid. Okay.
But let me just add to that. I'm sorry. Go ahead.
Go ahead.
No, I just wanted to add to that. And even if it is not installed yet in SP1, as Ken said, you can always drop us a line, and we'll be happy to give you the ones we have, so you can actually play around with it as well, and learn from it, and give your suggestions as well.
Yeah, exactly. So yeah, like I said, use our email address if you want these. If you want to start playing with these, send us an email. We'll send you the data structures. You guys can start installing. We just don't want to put them in the install just yet until we get a chance to quality check them. Okay. Any other questions? Sure. Okay. No, we've turned off the tool user type. Okay. You can do that. What I'm saying is right now what we have done for this demonstration is we've turned off the user type. Okay. You can leave it on. That's a function of let's see, SolidCAM.
By the way, what was the question? I can't hear the question, so if you can just repeat.
He's wanting to know what the search criteria is looking for.
Okay.
In the tool search, you can turn that on if you want to. And you could turn off, I don't think you can turn off tool type. Is there a reason we got tool type grade? There was, I forget what we were talking about on that. And there was a reason we would grade it out right now, but yeah, I think that's where because I think it was Herb that brought that up to us, wasn't it? Yeah, so we basically we're turning this off right now just to make it work. Okay, we're going to have to figure, because user tool type is completely arbitrary. You can't run structured logic off something that's completely arbitrary until we get built into the ability to do a conditional check against parsing a string. Okay. Now, we haven't built that yet. That it finds. Yes. Yes. So, like I said, we've got some more things we've got to do to it yet, but one of the things that we're going to be putting into it is going to be material definition. One of the other things we could do is we could put in it to look for a conditional check against a string. Okay. Right now we cannot apply a conditional check against a string because there's no code in there to parse the string. Okay. So it's all, we're thinking about it. Haven't done it yet. So other questions? Anybody? I can't hear you. I'm sorry. Okay. Oh. For blind versus through? Yeah, we're looking, what we're doing is Sydney explained it earlier, but you may not have been able to hear it. If the hole wizard is a through condition, then the hole diameter will be 0. The variable hole through diameter, or through hole diameter, excuse me, will have a value in it. So we're doing a conditional check against the value of one or the other of those to determine if it's using which one. Ultimately, and it's coming, ultimately, we were hoping to be able to do a Boolean logic check against a blind or a through condition. However, in the API, SolidWorks does not output end condition being blind or through. End condition represents, let me show you. In here, The end condition of it is looking at this list. And so there are multiple items that come out of that instead of just whether it's blind or whether it's through. It doesn't look at the condition physically of the solid model. It looks at which of this list was chosen. Now, I'll tell you right now, I doubt very seriously that we can get SolidWorks to create a variable in here for us. So what we decided to do instead was just simply teach how to look for whether the value is in hole diameter or whether it's in through hole diameter. It tells you immediately whether it's a condition blind or a condition through. It's not a logical check, but it works. Okay.
And this can also be seen, by the way, in the dump file, which you talked about yesterday.
Sid, hang on. Sid, hang on. He's trying to say something. I can't hear.
Sorry.
No. Well, that's in end condition. End condition will report that list. If you wanted to use it, yeah, you would have to build the logic into it. We're not going to build it in what we're going to install because we're not going to use it for that purpose. What we're going to put in the install is what I showed you. We're going to check for 0 or not. Okay. Sid, go ahead. I'm sorry. I didn't mean to interrupt you.
I'm sorry. It's okay. I can't hear the questions being asked anyway, so I don't know anyone speaking. But in any case,
okay.
If you just you can always create the dump file if you want. If you even have a moment or two, if you can still do it. Just create a dump file. You see all the different variables that we get there. You'll see that if the through hull will come out of 0, you can actually see it physically.
Yeah. Let me show them that real quick because we're running out of time.
Exactly.
Guys, what Sid just mentioned, I don't know if you could hear him or not, he was talking about the dump file. This is very important if you're going to be building these data structures, so let me show you how it works. Return here, go back here. Okay, so if I'm going to select the geometry and do this, and let me go back to ours, hang on a second. Okay, so when I go in here and I say I want to apply a machine process from the MP table, I'm going to use ours, so I'll just use the tapped hole right now. When I go to pick the geometry, if you use recognized geometry, now this is for the hole wizard, okay? If I'm using the recognized geometry, there is a check mark here for a dump file. So if I turn that on, anytime before I hit the green check, when I hit the green check, it's going to give me a dump file. And it's going to show me all the variables, and it's going to show what their values are coming from that selection. So think of this like the trace in the post. This kind of helps you walk through here and figure out what you got. What's the input to your output? So this, right now, this is our only diagnostic tool. I think we talked about building a trace type function, but are we staying with this, or is Grayson thinking about doing something a little more elaborate than this, more like the trace? Okay. So right now we've got this. Whether we'll build something like the trace or not is still to be discussed and figured out whether or not it gains us any benefit.
Okay,
because this gives you a lot of information. Say it again?
Yeah, let me just add one thing. If you look at the list, just want to point one thing out in the list, you'll see where Ken has marked off, it says tap drill diameter, and it has a value to it. You'll see a little further down it has through tap drill diameter, that's 0. So those, because if this particular case, that hole was a through hole, you get the value over there, and then the tap drill diameter will come out at 0.
Right.
That's the logic we're using.
Yeah, very, very good thing to say. So as you're looking at these different things, and this is something that in training we can go deeper into this. We're out of time today. An awful lot of information to try to plug into an hour here. But because I picked a tapped hole, notice the hole diameter is 0, right? And the through hole diameter is also 0, because in a tapped hole, those pieces go into tap drill diameter and through tap drill diameter. So you got to be aware of that. We'll try to document all that stuff for you and have it in the online text. Again, right now we just haven't gotten there yet. We've been running so hard trying to get this ready to show you what we're doing that we got some work still to do. But just be aware of that. If you pick a counter bore, it's going to be in the hole or through hole for the actual hole of the drill. The counter bore, of course, is going to be in the counter bore diameter. Okay. The upper countersink, if you put a chamfer on it, there's a near side countersink. There's a mid countersink. There's also a far side countersink. Obviously, we're not going to do a whole lot with far side countersink because we're drilling from the top side. Okay. Down the line, will we be able to do things like, you know, setting it up so it could go in with an expandable underneath countersink and then pull back out? Sure. It's not been done yet. Okay. So dive in and play with it, guys. Like I said, you know, until Service Pack 2, I'm pretty sure Service Pack 2 we will be installing a database. But right now in Service Pack 1, this is functional to the level that you see here. Call us, send us an email, we'll send you the data structure. You can plug it in on your system. Okay? What do you think? Oh, proud. All right, thanks, guys.
All right, take care, everyone. Have a great day.
Thanks, Sid. We'll see you.
All right. Bye-bye.
I was only supposed to have an hour. Yeah, 18 minutes over, so. Sorry. I screwed up.
What happened?
Nothing. We're just over time and shortening on something else, so.
Okay.
Check you later, man.
All right.
Bye.
Bye-bye.